Good morning and welcome to PrestoCon. It's really great to see so many people here already so early in the morning, especially on the West Coast in North America. It's really great to see everyone here. We have a really jam-packed day today, and I'm excited to see so many of the talks that Deepti and Girish mentioned. Once again, good morning. We'll start off by sort of like just, asking kind of like a fundamental question. What is Presto? And why are we all here for all these exciting talks today? So this is what I presented last time at the last PrestoCon. I think it does a good job of capturing many of the different aspects of what makes Presto really useful and important for so many people. So we'll just run through it. Presto is an open source distributed query engine that accesses data through pluggable connectors. So there's a lot to unpack in that sentence. And but for this talk, I'll approach it a slightly different way. And so we're at an open source conference, so this might be obvious, but Presto is free. And if, in case you didn't know that already, it costs you no money to operate it except the servers that it runs on. So that's like really kind of like a big benefit of open source is that you can use it all totally at no charge. But I would argue that Presto is free in more ways than it's simply not having a price tag. I would argue that a lot of Presto is really about what we don't do. And what it doesn't do, what it doesn't offer, and what it leaves up to you rather than deciding for you. So in other words, Presto gives you tons of choices and flexibility. So let's go through all the ways that Presto is free. So at the core of the technical development of the project is open source. It's at the heart of Presto. It's what makes it so important. All of the code is available for all to see in GitHub, so you can build it yourself from scratch if you'd like. There's a convenient Maven wrapper tool that's included with Presto. All the dependencies will get downloaded, and with one command, you can build it yourself. But once again, there's more to this than simply not having a price tag. So the first is that not only is the code available to see and fork, the license is extremely permissive. You're free to modify it and fork it and use it however you wish. But not only that, the code is written under the guidance of the TSC. So and guidance is sort of like a like a term that should probably be clarified. There's almost complete autonomy in changes, and really you just need a committer to approve your patch. The value of the TSC is that it's a completely independent body, and it's really its main goal is really to sort of like advance Presto, the technology, in ways that benefit everyone. The composition of the TSC is made up of people from lots of different companies who have lots of different interests, and we all sort of manage through that to have a shared vision on where we see the project going and the direction of the project. So that's like the TSC aspect of the project, and as Girish mentioned and Deepti, there's also the overall governance, very important to the operations of Presto and the advancement of Presto, the open source project. So I think that's all been explained very well, but it's very, very important to Presto is the fact that it's sort of like free, not controlled by one entity. It's led by consensus through the TSC. So another very important aspect is it's free to use and download. You can just, there's freely distributed Docker images where you can quickly spin up a Presto cluster. Even without Docker, you can download it from Maven Central and run it with the Java runtime. If you use Kubernetes, we have a Kubernetes operator that makes this extremely easy. So lots of different ways to get up and running with your Presto cluster. Not a whole lot of roadblocks or registrations or what have you to get that up and running. You can try it on your own laptop. So not only is it free to easy to download, use guided by an open source foundation, but you're free to take Presto in an incredible number of directions. Like as I'll elaborate through these slides, Presto is really about sort of like the freedom to take it in the direction that you want to take it. And as a general purpose tech, we support lots of different use cases that we don't even think about. And I think like these are some of the hallmarks of good sort of like ubiquitous technology, is that it enables all sorts of different use cases, many of which like maybe some technical contributors haven't even considered. And that's fine and accepted. We're not opinionated on how you want to use Presto, as long as you can use it well. And finally, there's a large technical community. There's lots and lots of people that use Presto. If you have a problem with it, probably someone's already encountered it and can help. If you need help for something, if you have a need for something within Presto, it's likely that someone else has had a similar need. So this openness not only means that you're free to use it however you like, but you get network effects from the larger technical community that you don't get in isolation. So not only do you know that the world's largest internet companies use it at really incredible scale and find out the bugs really quickly, but you know that there's a lot of people who use Presto to get their work done, who don't work there and can help you when you have similar problems as them. So in other words, it's not going anywhere. So that's sort of like freedom, in terms of like open source and like some of the aspects of like why open source is important, why it's critical to Presto. But not only that, the product itself encourages sort of like freedom in how you use it. And a very critical part of this is the connector API. And the way that we sort of like encourage connecting to all sorts of data sources is through the connector API. So using the connector API, you can connect to so many data sources that you may not have even considered using SQL to access. So it really sort of like not only, it's not really just an integration point, it's a way to unlock analytics in platforms that might be more closed without integration into Presto. So it's really sort of like a way to bring together all sorts of data sources without Presto having an opinion on what sort of data sources you should bring in. If you can find value from Presto, then it's okay. And not only that, but if we're, for example, if we're talking about particular connectors like Hive, that we support multiple different data file formats. If your file formats are in, like one particular open source standard, we support it, and we support customizations. Customizations are possible for file formats that maybe we don't know about. So we don't have a strong opinion on the file format that we use. It's agnostic to Presto, it doesn't matter. And also the table formats are also sort of agnostic to Presto. And we'll hear later more about Delta and Iceberg and others, and these are extremely important to the Presto community. So supporting even the way that the tables are laid out and like different ways to access them, extremely important to Presto. And we don't take a strong opinion on which one you should use. So we've talked about how Presto is free to use, and Presto itself is free to access an almost limitless amount of data from connectors. One other important thing about Presto is it's free to span multiple use cases. So this one's sort of like important and obvious, but interactive queries are sort of like a Presto, what Presto was originally developed for. So it's no surprise that this is the first on the list. It's probably the reason why most of you have come to Presto to begin with. But Presto works in a lot of other sort of like use cases that weren't originally considered. So for example, automated business intelligence tools. You don't have to ETL your data into a different data source and like hook it up with your business intelligence tool. You can load it directly against your warehouse and start to leverage insights immediately. Presto can handle high concurrency and low latency dashboarding use cases. So we've spent a lot of optimizations like making this really great user experience, really tuning this for low latency use cases, and we're excited to see more support and more sort of usage for low latency dashboarding type of use cases. And at the very opposite end of the spectrum, Presto can handle extremely large scale batch processing. So some companies that use Presto use it for batch workloads at high scale and leverage Presto's strengths as an interactive query engine to author and debug pipelines with very low overhead. So using, for example, an interactive query analytics tool like Airflow to kind of like quickly debug their query before deploying it to batch. The whole concept of sort of like debugging in real time, interactive, and then deploying it as a batch pipeline using the exact same language is extremely convenient, reduces a lot of overhead, and I think has the potential to unlock a lot of value for data engineers. So, and we'll see some at PrestoCon later, some slides and talks on some of the ways that we're scaling up batch workloads, which is really exciting. And then backfills, sort of like a flow on from batch ETL and so on and so forth. And there's many use cases that don't fit in the above conventional buckets, which are also good use cases for Presto. So one example is you may want to use Presto for some small scale data and leverage its query federation capabilities to give people a consistent interface into data from multiple sources. So less of an emphasis on traditional data warehousing needs and more of an emphasis on the query federation and language. And kind of like going back to what I was talking about earlier, that's a hallmark of a good general purpose technology, is that it can be used in ways that are completely unknown to the people who write the software and still be good, valid use cases in general. So we talked about freedom in terms of like the open source foundation, sort of like not being being governed in an open way, not being opinionated on where the data lives or how you access it. We also talk about Presto as free from freedom from something else. And what I would like to mention is that it doesn't bring its own special language that you need to learn from scratch to interact with Presto. It brings just one interface. We have to pick one. It brings just one interface that unites all the complexity underneath, and it's a language that you probably already know. And if you don't, it's extremely well documented and conventional, and it's ANSI SQL. Presto does not, for the most part, deviate from the ANSI SQL standard. And that means that you're not learning any vendor-specific additions. You're not second-guessing the semantics of your SQL. It's probably almost the exact same SQL you'd use for Postgres. And so you're free from the overhead of learning a new data frame API or learning what special constructs have been added to support whatever feature you need. We converge on the ANSI SQL standard because we have to pick one. And if we have to pick one, we want to converge on a standard that is independently documented and being adopted by the industry. And I would note that we were the first, among the first to do the sort of like converge on ANSI SQL. And not surprisingly, we see that ANSI SQL is becoming really popular for this exact reason. No one wants to learn a special Snowflake type of API for their database. They want to converge on something that is ubiquitous. And so this is sort of like a special call out from the previous point, but we include a lot of support for ANSI SQL, but we also support extremely complex multi-stage queries. We can support hundreds of thousands of stages, hundreds and thousands of stages, lots of aggregations and joins. And so I would argue that we're ultimately limited not by what we support typically, but by the hardware and efficiency. And as I'll mention later, we're doing a ton of work on efficiency, so we can only expect this to get better. So you don't come to Presto only to find out that we've made some sort of trade-off where we think speed is more important than, for example, having support for more than 100 stages. You come to Presto for complete support and are only limited by the hardware's capability to run your extremely complicated SQL. And once again, this is yet another call out from ANSI SQL support, but it's worth highlighting that we support ANSI SQL over all data sources, even data sources that don't support SQL. So as I touched on earlier, the power of SQL can be unlocked on platforms that don't traditionally support SQL. So we get, I would argue, a force multiplier effect by unlocking data that might traditionally be viewed as siloed. So just to recap, Presto is free. You don't pay for it. That's the obvious thing. But there's a lot more to that. It's free to modify and extend however you want. We run an open foundation that is neutral and allows for anyone to bring features and capabilities to the table. You may not need to bring any custom features to open source at all, though, because our APIs are extremely flexible, and we're designed like that from the beginning. We also support for many varied use cases that range from high volume, high QPS use cases to large scale batch ETL to small scale API abstractions, and all sorts of combinations of these configurations. So it's not opinionated in how you use it. You're free to use it however you get value from it. And I would argue there's lots of different combinations where you get tons of value. And finally, you're free from having to learn a totally new language when you interact with it. You use one familiar standards-based language that the industry is converging to anyway. So is that all? Have I described everything there is about Presto? And the answer is no. What we were talking about earlier is how Presto allows you to use it without restriction for tons of analytical use cases. But there's something deeper that's also extremely important. You can create another platform that mimics all of these things that I discussed in kind of like similar ways and gets a similar value. But there are engineering fundamentals that are extremely important. After all, Presto is extremely complicated, and without good fundamentals, it can fail in ways that are extremely hard to understand. So what are the fundamentals? So the first is that Presto is used at an enormous scale. So it's scalability. Presto is designed for scalability. We know that it scales really well because lots of huge companies invest in Presto and prove that it works for data warehouses that are truly large. So we know that like if there is an upper bound, it's a really huge upper bound, and it's larger than what most people typically have in their own data warehouse. So and we have really big companies that operate this successfully. So we know that it can be done, and we know that it is done, and we know that it's done in a very reliable way. Not only that, but we have cloud providers that offer Presto at any scale, that offer Presto at scale. And we also know that it works very well for cloud environments. And what I mean by this is, in particular, disaggregated storage environments where your compute may be, sort of like separate from your storage, such as S3 with EC2. So then let's move on to reliability. If you had a service that was open and free and could scale really well, but failed, let's say, a quarter of the time, you probably wouldn't use it. Reliability is extremely important, and it's a bedrock feature of Presto. And it really spans everything that Presto does. And so there is a ton of eyes on basically all aspects of the code that help to root out issues, help to make the system more reliable. And kind of like going back to my earlier point, we know that it could be run reliably at truly massive data warehouses. We know that, for example, it can scale to, tens to thousands of nodes. And this tremendous amount of runway to scale Presto as you scale your own business or needs is, I would argue, pretty powerful. Not only that, but Presto can spill to disk. You can configure Presto to spill and prevent failures when the size of your queries exceeds the limits. We've put a lot of investment in that in the past couple of halves. And final, Presto also now supports multiple coordinators, allowing you to drain and add coordinators as you would a worker, meaning less single points of failure and allowing you to maintain delicate infrastructure without causing an outage. My colleague Swapna will be talking more about this later today. There's also multi-tenancy support in Presto, which means that it's been designed to support various clients that execute at various different rates and retrieve data at various different rates, all while ensuring the resource management is efficiently utilized. And finally, we get to speed. So you have an open foundation with a query engine that's reliable and scalable, but it's super slow. There are query engines out there like that, and Presto aims for speed and reducing the time that it takes to get to first insights where possible, all the while supporting complex multi-stage queries in a multi-tenant environment. The first aspect is streaming shuffle. When Presto exchanges data, it streams it rather than materializes it to disk, which means that the data is processed in real time and you wait less for your data. Most operators support code generation where they benefit, which means that your query ends up getting compiled and optimized for the particular shape that you send, and repeated queries end up reusing these optimizations. Presto operates column by column, which is critical for maximizing the underlying hardware to its full potential and avoiding the expensive branch mispredictions in the CPU. And as we've talked about in previous PrestoCons, Presto supports multi-tiered caching with intelligent workload placements and routing that maximizes cache efficiency. So we see that this allows for the use of disaggregated storage, which tends to be cheaper to operate and saves the organization money with latencies that are comparable to co-located flash. Sort of like getting the best of both worlds with intelligent caching. This is done, and then K1 will be talking about this later today. And then Presto also supports complex filter pushdown. In Project Aria, we've implemented pushdown support all the way down to orc. This is being extended to Parquet, and this gave lots of performance benefits to selective queries. It adaptively reorders the filters to choose the most selective filters first, and prevents materialization all the way down at the orc region level. So we've talked a lot about, like, I think, what makes Presto a great general purpose technology. We've talked about like the fundamentals that make it an excellent platform that has been proven out in many different large scale deployments. So the question is, what's next on the docket? And the answer is more. We want more of everything. We want to further improve Presto's fundamentals and allow this awesome general purpose tech to scale to all sorts of workloads, making Presto your very first choice for anything analytical. And the first step is scalability. So Presto and Spark is out there. We're going to be giving a very exciting talk on that later today, and it's already being used in production workloads. We're going to continue to invest in it so that it can continue to scale well. Coalescing small files, replanning in between stages, and taking advantage of statistics written in previous stages, and optimizing it for latency. If you have a Spark deployment as well, we want it to be as easy as possible for you to move your Presto query onto Spark and allow it to scale to batch workload sizes without even having to think about rewriting a query. So pretty good scalability on batch. We want to further improve Presto scalability, support multiple thousands of nodes. So there will always be an upper limit. It's not magic, but we want to continue to push that number higher and higher so that you don't have to think about it as you scale your own workloads. Reliability is at the core of everything. We want to be continuously investing in reducing failures due to queries, making the platform rock solid, improving multi-tenancy support, and continuing to invest in reliability. And we want to continue to push the envelope on how fast we can make Presto. And we've been putting some significant investment into this. We have a lot of talks coming up today on our efforts on rewriting Presto eval engine in C++. There's such a great amount of potential here to reduce latency, increase efficiency, and do more with less, all while supporting the same query shapes as we have before. And so we've seen this with some commercial offerings recently. They've done this with pretty good success. And that what excites me, though, is doing this in an open source platform and giving it to the world. So stay tuned for sessions from Intel and Meta on Velox and Prestissimo and the architecture behind it and the real world improvements that we're seeing. It's extremely exciting, and I really couldn't be more proud of this effort, which I think could be the largest undertaking since Presto was even created. On top of that, we're investing in reducing tail latencies in the face of unstable hardware. So everyone knows the familiar adage in distributed systems, which is, or most likely does, which is that you're as fast as your slowest machine. We're changing the game on that and investing in speculative execution to decrease latencies, giving more predictable query performance and making hardware failures less noticeable. And we'll be talking about this today, materialized views. You can integrate your pre-materialization into the engine itself, create roll-up tables without having to leave Presto, and think about having to create another pipeline. So we're very excited about that as well. And finally, we can't get there without you. So a lot of this future really depends on the community. Your participation is valued, and it could be like one of the most important aspects to Presto is the participation of the community. And there's so many ways to get involved. In Slack, there's PrestoDB.slack.com. Here you can ask questions, ask like how to get started on development, like where to file issues, all sorts of things. It's a great general purpose forum to talk about Presto and sort of figure out the lay of the land. You can file issues on GitHub for missing functionality or ideas that you have for Presto. So you just go to PrestoDB/Presto GitHub, file an issue, and get that going. You can take open issues and offer to work on them. Presto, takes time to understand, but it's also not the most difficult platform. I think anyone, especially Java developers, but pretty soon also, as I mentioned, C++ developers, can get started. Contribute blog posts for Presto. If you have a use case, if you've been using Presto internally, you might think that it's boring and not interesting, but actually there's so much different variety out there. I think every single use case has some interesting aspects to it. So please, consider to put a blog post on how you use Presto and what you use Presto for. It's a learning opportunity for everyone else who's operating Presto out there. And then finally, you can contribute code. It could be a new connector, it could be a bug fix, what have you. We accept contributions, as I said in the beginning of the slide. And so I think I'm a little bit over time, but I just wanted to say thank you once again for attending PrestoCon. Thank you for your participation. I'm really excited for some of the upcoming sessions and looking forward to that. And I'll see you at the upcoming presentations. Thank you.